Today we are learning about graphing quadratic equations. So we have solved quadratic equations a lot of different ways, and I've always told you that the answers that you are getting are the x-intercepts. So today you'll see that. So I know I've got this one. I can graph quadratic equations in the form of y equals ax squared, graph quadratic equations in the form of y equals ax squared plus bx plus c, and use the vertex formula to determine the vertex of a parabola. So the key vocabulary are parabola, vertex, axis of symmetry, and intercepts. The graph of a quadratic equation is called the parabola. The highest point or the lowest point on a parabola is the vertex. The axis of symmetry is the line that runs through the vertex and through the middle of the parabola. The vertex of a parabola has the x-coordinate of negative b over 2a. The corresponding y-coordinate of the vertex is found by substituting the x-coordinate into the equation and evaluating y. So graphing quadratic equations, you first find the vertex by using the formula x equals negative b over 2a. Don't forget to find the y value. Then find the intercepts. So let x equal 0 to solve for y-intercepts, and let y equal 0 to solve for x-intercepts. And then plot the vertex and the intercepts, and then find any additional points on the graph by plugging points in for x in your equation to find y, and then draw a smooth curve through the plotted points. Keep in mind, if a is positive, it opens up, and if it's negative, it opens down. All right, so number one, we're going to graph g of x equals 3x squared. All right, so to first start out with this, I just want to show you how you can plot points. So if I plug a 0 into 3x squared, I would get 0. If I plug a negative 1, watch, if I plug, let's see, a negative 1 in, I would get 3. If I plug a positive 1 in, I would also get 3. If I plug a negative 2 in, negative 2 squared is 4 times 3 is 12. And then if I plug a positive 2 in, 2 squared is 4 times 3 is 12. So if I plot those points, I get this parabola. So you can find this just by plugging in points. So let's do the next one. So 1b, again, okay, so let's do this one. We are going to come up with some points, okay? So I'm going to say from negative 2 to 2. So if I plug those in, negative 2 squared is 4 plus 3 is 7. Negative 1 squared is 1 plus 3 is 4. 0 plus 3. 1 squared plus 3. 2 squared plus 3. Okay, so you can plot those points and you would have it. And so if you did, your answer would look like that. So let's go back a second. Let's see if we plotted this, okay? I'm going to try to do this. Oh, that's horrible. Okay, let's try this again. Okay, so 1, 2, 1, 2. Then I went 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to plug negative 2, 7, negative 1, 4, 0, 3, 1, 4, and 2, 7. And then I'm going to connect it with a line, a curved line. Okay, so the lowest point is called the vertex. And that coordinate is at 0, 3 on this one. That is also your only y-intercept, and you don't have an x-intercept. Okay, 1c, you're going to graph the following. So I want you to try these just by plugging in points. Pause it. So that's C, D, and E. And notice, I want you to notice something. When A is positive, so when the number in front is positive, so that's positive 1 and a positive 2, it points upward. The parabola opens upward. But when you have a negative, it opens downward. Do you see? This is what I'm talking about. It opens downward. All right, now we're going to graph this by labeling the vertex. Okay, so we want to label the vertex first. So you are going to use the vertex formula, which is negative b over 2a. So if I did that, negative b, it's a negative 6 already. So negative 6 would be a positive 6 over 2a. So I get 6 over 2, which is 3. So my x is 3. So the vertex, I know my x coordinate right now is 3. So to find the y, I'm going to plug that in for every x and solve for y. So I would get 9 minus 18 plus 7. So 9 minus 18 is negative 9 plus 7 is negative 2. So my vertex is 3, negative 2. Okay, so I'm going to plot this at 1, 2, 3, negative 2. Now I need to look for other intercepts and stuff. So if I plugged in a 0 for my x's, my y would be 1, 2, 3, 4, 5, 6, 7. This is my y-intercept, okay? Now, I know that my parabolas are symmetrical around a line called the axis of symmetry. So it's a vertical line through the vertex. So if I'm 3 away there, then 3 away symmetrically across from that would be right there. So, okay, let's go back to this. My axis of symmetry is where x equals 3. So if I count 3 this way, I can count 3 this way and plot another point. Now, another thing that you can do to get more points is to find your x-intercepts. And so let's write the equation again. Remember, so your x-intercept is where your y equals 0. So I'm going to factor this. Can I factor that? Is that possible? No, it's not factorable. So I can't do that. So that's not going to work. All right, so if it's not factorable, what you can do is you can plug in points for x. So I would like to know what was happening, maybe say where x is 1. Let's see what happens with y when x equals 1. So if I plug that in, I'll get y equals 1 squared minus 6 times 1 plus 7. So 1 minus 6 plus 7, that would be negative 5 plus 7, and I would get 2. So where x is 1, y is 2, which means if it's 2 away this way, it would be 2 away this way. And then my line would just be a curved line through those points. And that is their pretty graph, but it's the same thing. All right, 2b, graph and label the vertex. Okay, so remember the vertex formula is negative b over 2a. Well, I don't have a b because there's like no x there. So it would just be 0 over 2, which is 0. So I'm going to plug in my vertex so far is 0. So I'm going to take that value for x and I'm going to plug it in the formula that I was given. And I get that y equals 2. So my vertex is at 0, 2. Okay, so I'm going to plug in that point, 0, 2. Now what I know is that this thing is pointing upward because my leading coefficient is positive. So I know it's going upward, okay? Which means that I know it's not going to have any x-intercepts and my y-intercept is already plotted. So I need to figure out what's happening on either side of that. So I'm going to say let x equal -1 and +1 because those are 2 points on either side of my vertex. So if I did that, I would get y equals -1 squared plus 2. So that would be 3. And if y equals +1 squared plus 2, that's also 3. So I want to plot those points. -1, 3, +1, 3, and then you can plot the graph. Okay, let's do another one. So we're going to graph this and label the vertex. So we've got x equals -b over 2a. Uh-oh, it's a fraction. So we have the x equals negative 7 over 2. So in my vertex, I'm going to say negative 7 over 2, which when I plot that, that's going to be negative 3.5. Okay. So if I plug that in, negative 7 over 2 squared plus 7 times 7 over 2 plus 10. Nobody said it was going to be pretty. Okay, so 49 over 4 plus 7 times 7, 49 over 2 plus 10. This is a negative right there. Okay, negative 7 over 2. There we go. So we've got, let's get this in like denominators. Okay, so 49 over 4 minus 98 over 4 plus 40 over 4. So 49 minus 98 would be negative 49 plus that 40 over 4 would be negative 9 over 4. So my vertex is really ugly. So this is negative 3.5 if I was graphing that, and that would be negative 2.25 ish. Okay, so let's do it. Now, obviously you can't do it perfectly, but let's just estimate as good as we can, okay? So we're gonna have, all right, let's do this. So we've got negative 3.5, negative 2.25. It's estimated about there. Okay, now let's get some other intercepts. So what do you know? You know that it's pointing upward, right? Because this is positive. You know your y-intercept is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Way up there. Okay, now let's get something closer. So I'm going to say, all right, can I find my x-intercepts? So if I did the original formula, is that factorable? Yes, it is. So 2 times 5 is 10 and 2 plus 5 is 7. So that tells me that my x-intercepts are negative 2 and negative 5. So I know I've got right here and 1, 2, 3, 4, 5 right here. So this graph, if I wanted to extend it all the way up there, I could, but it looks like that. So let's see what their pretty graph looks like. Let's see, hold on. Let me close this parentheses because it's going to bother me. Okay. And look how much prettier theirs looks. That's just sad. But we have all the same information. So the x-intercepts are at negative 2, 0 and negative 5, 0. Their y-intercept is at 0, 10. And their vertex is at negative 7 over 2 and negative 9 over 4. Okay, let's try another one. Okay, we have to find the vertex first. So x equals negative b over 2a. So I'm going to say negative 6 over 2 times negative 1. So negative 6 over negative 2 is 3. That's much better. Okay, now I'm going to plug that in to find my y. All right, I want you to see something. I am not squaring the negative sign. I am just squaring the x. So this is actually negative 9 plus 18 minus 9. And if I do all that, I would get negative 9 plus 18 is 9, minus 9 is 0. Okay, so let's plot this at 3, 0. I know that it's pointing downward and that my y-intercept is at negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is at 0, 9. This is at 3, 0. If I'm 3 away this way, then I need to be 1, 2, 3 away this way. Because my axis of symmetry, remember that imaginary line is right through here. So 3 away, about right there. And I could just draw it like that. That would be fine. But I just want to see maybe what's happening at x equals 1. So where x is 1, let's see what y is doing. So I'm plugging it back in the original formula. So y equals, that would be -1 plus 6 minus 9. So that'd be 5 minus 9 is -4. So 1, -4. So if I'm 2 away here, then 2 away here would be right about that. And then you connect your dots. Oh, goodness, this is way harder than it looks. Okay. And that is your graph. See how pretty theirs looks? All right, now you get to try a few. So go ahead and pause this. You're going to graph them and label the vertex. So that is E, F, and G. And notice again, the two with the negative signs are pointing downward and the one that's positive is pointing upward. So I know I've got this one. I can graph quadratic equations in the form of y equals ax squared, graph quadratic equations in the form of y equals ax squared plus bx plus c, and use the vertex formula to determine the vertex of a parabola. But do you really understand? How can you tell whether the graph of the quadratic equation such as y equals 2x squared minus x minus 6 opens upward or downward? If the leading coefficient is positive, then it opens upward. If it's negative, it opens downward. Describe how you would use the vertex formula to find the vertex of the parabola y equals x squared minus 4x plus 3, and then find the coordinates of the vertex. So pause this and try. So you should have gotten to use the formula x equals -b over 2a, and then the y coordinate can be found by substituting the x coordinate into the equation and solving for y. The vertex that you would have found is 2, -1.